Hello and welcome to our session on the principle of moments. In this session, we will explore a fundamental concept in physics, critical for understanding rotational equilibrium. The principle of moments states that for an object to remain in rotational equilibrium, meaning it is not rotating, the sum of clockwise moments about a pivot or axis of rotation must equal the sum of anti-clockwise moments about the same pivot. In other words, the resultant moment on the object must be zero. Let's dive into an example. We have a uniform meter rule with a weight of 2 Newton pivoted at the 70 cm mark. The question is, will the rule topple about the pivot? To solve this, we calculate the moments about the pivot. Clockwise moment, a force of 5 Newton acts at 30 cm from the pivot. Using the formula, moment equal to force times perpendicular distance from the pivot, we get the clockwise moment to be equal to 5 Newton times 0.30 meter equal to 1.5 Newton meter. The anti-clockwise moment, which is the weight of the rule, 2 newtons that acts at 20 cm from the pivot, and applying the formula, the anti-clockwise moment is equal to 2 Newton times 0.20 meter, which is equal to 0.4 Newton meter. Subtracting this gives us the resultant moment of 1.5 Newton meter minus 0.4 Newton meter, which is equal to 1.1 Newton meter clockwise. Since there is a resultant moment, the rule will rotate clockwise about the pivot. Now, let's tackle another exercise together. In the diagram, a uniform meter rule is pivoted at the 50 cm mark with forces acting on both sides. To balance the rule horizontally, we are to calculate the magnitude of force F. The anti-clockwise moment is equal to 5 Newton times 0.40 meter plus 2 Newton times 0.35 meter, giving a total of 2.7 Newton meter. The clockwise moment is the force F acts at a distance of 0.20 meter, giving the expression F times 0.20. Using the principles of moments, where the anti-clockwise moment is equal to the clockwise moment, F times 0.20 is equal to 2.7 Newton meter. Solving for F, we have F equal to 13.5 Newton corrected to 3 significant figures. This ensures the meter rule is balanced. An object is in complete equilibrium when two conditions are met. First, the resultant force acting on it is zero. Second, the resultant torque or moment acting on it is zero. This aligns with Newton's first law of motion, which states that an object at rest or moving at a constant speed in a straight line will remain so unless acted upon by an external resultant force. Let's recap the key points. Newton's first law of motion. Newton's first law states that an object will remain at rest or continue to move in a straight line with constant speed unless acted upon by an external resultant force. This principle applies to rotational equilibrium as well. For an object to stay balanced and not rotate, there must be no resultant force and no net moment acting on it. 4 things a force can do. It can change the shape of an object, change the size of an object, change the speed of an object, change the direction of motion. There are two types of forces. Contact forces. These require physical interaction, such as friction, tension, and normal forces. Non-contact forces. These act at a distance, such as gravitational force, magnetic force, and electrostatic force. For example, weight W equal to mg is a non-contact force caused by gravity, where m is a mass in kilogram and g is gravitational field strength 10 meter per second squared. Free body diagrams are diagrams which represent all the forces acting on an object, including objects on slopes. Forces are drawn as arrows, vectors, with the length of the arrow representing the magnitude of the force. Moments, also known as turning effect of forces, is defined as the product of a force and its perpendicular distance from the pivot or axis of rotation. There are two types of moments. Clockwise moment, the turning effect is in the clockwise direction, and anti-clockwise moment, the turning effect is in the counterclockwise direction. Moments are vectors because they have magnitude and direction. The unit is Newton meter. It is important to identify the perpendicular distance from the line of action of the force to the pivot to calculate the moment. Lastly, principle of moments. For rotational equilibrium, the sum of clockwise moments must equal the sum of anti-clockwise moments about the same pivot. This principle allows us to solve problems involving balance and rotation.